Imagine standing next to a modern skyscraper's drainage system. Pipes engineered with computer precision, designed to handle millions of gallons of water. Now, erase all of that. Go back 500 years. High in the Andes, a civilization with no iron tools, no wheels, and no written language built a mountain palace that manages water better than many cities can today. But here's the problem. Machu-Picchu sits on top of two massive fault lines. It rains half the year, sometimes violently. The mountain should slide, the foundations should wash away, and yet, after 5 centuries, it hasn't moved a single centimeter. How is this possible? In this documentary, we are not looking at pretty ruins. We are looking at an engineering masterpiece that challenges everything we think we know about ancient technology. You are about to discover the secret engineering of Machu-Picchu, and nothing you have learned about history will feel the same again. Hidden 8,000 feet above sea level, carved into a ridge so steep that most modern architects would walk away, Machu-Picchu has survived earthquakes, landslides, and 500 years of tropical storms. But the Incas left no blueprints. No written records explain how they built it, and that silence has created one of the greatest mysteries in engineering history. Over the next few minutes, you will see how they moved stones heavier than a loaded Boeing 757, how they built an invisible water system that still flows perfectly today, how they designed earthquake-proof walls that actually dance during tremors instead of collapsing, and why modern engineers, with all our technology, still struggle to explain one specific feature hidden beneath the grass. But before we go underground, we need to start with the man who revealed this place to the modern world. It is 1911. An American historian named Hiram Bingham is searching for the last Inca stronghold. He is not expecting to find anything truly lost. Local farmers already live in the area. But when a young boy leads him up a cloud forest slope, Bingham stops cold. He is standing in front of walls made of white granite blocks, each cut so perfectly that a knife blade cannot slide between them. No mortar, no cement, just stone against stone. Bingham writes in his journal that the site was so unexpected, so perfectly preserved, that he thought he was dreaming. But here's what he did not understand. The Incas had no iron chisels, no steel. Their hardest metal was bronze, which is softer than the granite they were cutting. So how did they shape these blocks? Even today, quarrying granite requires diamond-tipped saws or high-pressure water jets. Modern engineers have tried to replicate Inca stonework using the tools available at the time. They have failed, repeatedly. The leading theory involves hammerstones and endless patience, but that theory has a problem. Hammerstones leave impact marks. The walls of Machu Picchu show almost none. So were they softening the rock somehow? Did they have a plant-based acid that etched the granite? Archaeologists have found no evidence, and that leaves an open question. How do you cut granite with a rock that is softer than granite itself?
Now imagine the challenge of moving those stones. The largest granite block in Machu Picchu weighs roughly 20 tons. That is heavier than a fully grown Tyrannosaurus rex. The quarry where the Incas sourced this stone sits 800 meters below the city, on the opposite side of a deep river valley. There is no flat path, no road, just a sheer mountain face and a roaring river. Modern construction companies would use helicopters or heavy cranes. The Incas had neither. So how did they do it? Archaeologists have found evidence of ancient ramps and levers, but nothing that fully explains the vertical lift. Some researchers believe hundreds of workers pulled each stone using ropes made from plant fibers. But here's the problem with that idea. Plant fiber ropes break under even loads. A 20-ton stone swinging on a rope would have snapped those fibers instantly. And even if the ropes held, how did they coordinate hundreds of men on a slope so steep that falling meant death? Think about this. The Inca Empire had no written language, no way to record complex engineering calculations, and yet they executed a logistics operation that would challenge a modern general. The mystery is not just about strength, it is about knowledge. What did they understand about leverage, friction, and gravity that we have forgotten? But the stones themselves are only half the secret. The real engineering genius of Machu Picchu is hidden underground. In 2004, a team led by hydrologist Kenneth Wright made a shocking discovery. Beneath the grass and soil, the Incas had built a completely invisible drainage system. 129 separate channels, all carved into the bedrock, all precisely angled to carry rainwater away from the foundations. Wright calculated that this system can handle a 100-year storm, the kind of deluge that would turn most mountain towns into mudslides. And here is the impossibility. The Incas had no way to survey the underground slope. They could not see the bedrock beneath the soil, and yet their channels follow the natural geology perfectly, as if they had X-ray vision. Even today, civil engineers use ground-penetrating radar to map subsurface water flow. The Incas did it by hand. How? Some researchers suggest they studied how water moved after every rain, adjusting their channels over generations. But that theory has a weakness. Machu-Picchu was built in less than 100 years. That is not enough time for trial and error on this scale. So what if they understood something else? What if they could read the mountain itself, sensing the flow of water through changes in vegetation, rock temperature, and soil moisture? We do not know, and that uncertainty has forced modern engineers to admit that ancient Andean hydrology still has lessons to teach us. Now, let us talk about earthquakes. The Andes are one of the most seismically active mountain ranges on Earth. Machu-Picchu sits directly on two intersecting fault lines. That is not a mistake. The Incas deliberately built on faults because the fractures provided ready-made sources of stone and water. But building on a fault line is engineering suicide, unless you know a secret. The walls of Machu Picchu are not straight. Look closely and you will see that every door and window tilts inward slightly, narrowing at the top. The corners of buildings are rounded. The stone blocks fit together with a technique called ashlar masonry, where each block is cut to lock into its neighbors like a three-dimensional puzzle. During an earthquake, straight walls crack and collapse, but these walls move. They shake, they shift, they settle, and then they fall back into place. Modern seismic engineers call this technique passive tamping. They only figured it out in the last 50 years. The Incas were doing it 500 years ago. But here's the question that keeps structural engineers awake at night. How did they test this? You cannot learn seismic design through trial and error without experiencing earthquakes. And if you experience a major earthquake, your building collapses. So either the Incas got it perfectly right on their first attempt, which is statistically impossible, or they had some way of predicting how stone would behave under stress that we have not rediscovered. What did they see that we are missing?
Perhaps the most mysterious feature of Machu Picchu is something most visitors walk right past. The Incas built more than 700 agricultural terraces, stair-stepping down the mountain slope. At first glance, these look simple, just retaining walls filled with soil. But in 1983, archaeologists made a strange discovery. The soil in the terraces did not come from the mountain. It was imported from different elevations, some from valleys miles away. And the Incas had layered it intentionally. Gravel at the bottom for drainage, sand in the middle, rich topsoil on top. Then, above that, a second layer of gravel. This created a capillary break, preventing groundwater from rising up and salting the soil. Modern agronomists understand capillary breaks. They learned about them in the 1970s. But here is where it gets truly strange. Each terrace has a different soil composition, matched specifically to the crops grown there. Potatoes at the bottom, where it is warmer. Maize higher up, where the nights are colder. And between each terrace, a hidden canal that captures rainwater and sends it to the next level down. The entire mountain was transformed into a living machine, a self-watering, self-draining agricultural system that produced more food per square meter than any farm in Europe at the time. So how did the Incas know about capillary action, soil chemistry, and microclimates? They had no universities, no microscopes, no written agricultural manuals. And yet they engineered a system that modern organic farms are only now beginning to imitate. Ask yourself this: if their knowledge was so advanced, where did it come from, and why did it disappear? Let us return to the water system, because this is where the deepest mystery lives. The Incas built a spring capture structure at a source 3/4 of a kilometer uphill from the city. From there, a stone-lined canal carries water at a precise 1 to 3% grade, fast enough to keep sediment from settling, but slow enough to prevent erosion. That canal delivers 15,000 gallons of water per day to a series of fountains inside the city. The first fountain flows into the second, which flows into the third, all the way down the mountain. Every fountain has a different spout design, tuned to the volume of water available at that elevation. And here is the part that modern hydraulic engineers find humbling. The system has no filter, no sediment trap, no chemical treatment, and yet the water coming out of the lowest fountain is still clean enough to drink today. How? The Incas built small settling basins at each turn, places where sand and silt could drop out of suspension. They lined the canal with smooth stones to prevent algae growth, and they buried sections of the canal underground to keep the water cool and biologically inactive. But they had no understanding of microbiology,
no concept of pathogens. And still, they designed a system that avoids contamination better than many rural water supplies in developing nations today. Was this accidental? Or did they know something about water that we are only now relearning through expensive trial and error? The answer is not written in any book. It is carved into the mountain, waiting for someone to ask the right question. Where are you watching from right now? Think about the building you are sitting in. If the power went out, if the water stopped flowing, how long would that building remain habitable? A week? A month? Machu-Picchu was designed to function indefinitely without any external input. No electricity, no pumps, no chemical treatment plants, just gravity, stone, and a deep understanding of natural systems. And that brings us to a philosophical question that most historians avoid. Why do we assume that ancient people were less intelligent than us? They had different tools, different materials, but their brains were identical to ours. And when you look at Machu-Picchu without the arrogance of modernity, you see something humbling. You see engineers who solved problems we still struggle with, using methods we cannot fully replicate. The spring still flows, the canals still carry water, the walls still stand, and 500 years from now, long after our concrete skyscrapers have crumbled into dust, Machu Picchu will still be there, holding its secrets close. So what is the deeper idea here? It is not that the Incas had alien help or magical powers. It is that human knowledge is not a straight line upward. Civilizations rise, discover profound truths about the natural world, and then those truths get lost in the chaos of conquest and collapse. The engineering of Machu Picchu represents a peak of understanding about stone, water, and seismic forces that we are only now climbing back toward. And the most unsettling thought is this: if the Incas could lose that knowledge, what knowledge are we losing right now? What skills, what insights, what ways of seeing the world will future archaeologists marvel at, unable to explain how we built the things we built? The mountain doesn't answer. It only stands there, silent and patient, waiting for us to ask better questions. And that is the real secret of Machu Picchu. Not how they built it, but what we have forgotten about how to live on this earth. Let me know in the comments what you think they understood that we do not. And if you want to go deeper into lost engineering, stay curious. The past has not finished teaching us yet.